Hello viewers, today we are going to talk about block diagram of electronic communication system, functional description of subsystems, electromagnetic spectrum and modulation. An electronic communication system is designed to transfer information from a source node to one or more destination nodes over space or time. If you look at the functional block diagram, you can see there are 7 major components of a communication system. First one is information source node. Information source node generates the information which is to be communicated and is desired by destination node. Input transducer converts information signal into an electrical signal which is suitable for transmission over electronic communication system. Then transmitter accepts input transducer and converts into a signal which can be transmitted reliably over a channel which connects the source and destination nodes. Channel is the physical medium which connects source node and destination node. Receiver's job is to get signal from the channel and take a decision by extracting the message from the information signal. Output transducer converts the electrical output of the receiver into a message signal which is useful to the destination node. In the subsequent slides, we are going to describe the functionalities of each of these subsystems in detail. The first one we will focus on is information source. Information source is a source whose output is described in probabilistic terms, that is, the output of information source is not deterministic. If the source has deterministic output, it will generate an average rate of information which is 0 and there is no need to describe it through a electronic communication system. The examples of information sources are voice, camera picture, video stream, temperature data or text messages in some particular language such as Hindi, English, Tamil, etc. Input transducer, it converts the information source output into an electrical signal that is suitable for transmission by an electronic communication system. Examples of transducers are microphone, which converts voice signal into speech electrical signal, camera, which converts images into pictures into electrical signal, camcorder, which converts video into electrical signal, thermistor, which can convert temperature data into electrical signal suitable for transmission by electronic communication system. Another example could be optical character recognition system, which can convert text messages into electrical signals. Now, the output of input transducer is given to transmitter. Transmitter's job is to convert electrical information signal obtained from the output of input transducer into a form that is suitable for transmission through the physical media. The transmitter can involve certain signal processing operation including modulation, which is mapping of information signal onto a carrier, and or frequency translation or shifting to match frequency assigned to the transmitter. Another job could be signal amplification to have suitable coverage. Signals, when they are transmitted over the physical media, they are attenuated. So, in order to have a desirable coverage area, we need to suitably amplify signal before transmission. Another job of a transmitter is signal filtering, which allows the distortions introduced by channel to be minimized. If the system what we are designing is a wireless system, then additionally transmitter will have antennas. Signals from the output of transmitter are sent to the channel. Channel is the physical media which is used to send signals from transmitter to receiver. This is the media which connects sender to the receiver. When signal is transmitted over the channel, there are several signal impairments which are introduced. These impairments are noise, distortions and interference. The amount of impairments introduced on the signal depends on the type of channel, which we can classify in 3 categories. One is guided or wired channel, another one could be unguided or wireless channel. These two channel types are used for communication over space. If we are talking about communication over time, then the channel is typically a storage device like hard disk, pen drive, CD drive, anything can be used to store information, and at some other point in time we can retrieve information from the drive. To get more details about the type of media which we use in communication, let us go to the next slide, and this figure shows 3 types of wired media. One is twisted pair, another is coaxial cable, and third one is fiber optic cable. These 3 medias, based on the requirement, are used extensively in our day-to-day use. Like twisted pair cables are used for connecting computers or connecting the telephone line to the switch. Coaxial cables are typically used for TV signal transmission, and fiber optic cables are used for intercontinent communication channels. They provide high capacity links. So, in storage devices we can have memory card reader, USB flash memory, media devices like iPod or hard drives or external CD drives. These drives are used for storing information, and based on the different requirements we can use any of these storage media to store information which can be retrieved by the same person or some other person at a different point in time. Talking about unguided media, typical medias which are used are free space and underwater channels. Free space is used extensively for radio and TV broadcast as well as for mobile communication, which is part of our day-to-day life, and underwater communication is mainly typically used by submarines, where they have to communicate their information to the base stations. So, this free space or underwater communication uses wide range of frequencies which we call as electromagnetic spectrum. Typically frequencies starting from 3 kilohertz to several terahertz are being used for different kind of communication systems. We can divide the spectrum in several bands. This band designation is as per the International Telecommunication Union. So, the frequencies from 10 hertz to 10 kilohertz are called very low frequency, then 30 kilohertz to approximately 300 kilohertz it is called low frequency, then 300 kilohertz to 3 megahertz is medium frequency, then 3 megahertz to 30 megahertz is high frequency, 30 megahertz to 300 megahertz is very high frequency, and 300 megahertz to 3 gigahertz is ultra high frequency. 3 gigahertz to 30 gigahertz is called super high frequency, and 30 gigahertz to 300 gigahertz is called extra high frequency. Now, beyond that there are spectrums which are named infrared, visible, ultraviolet, X-ray, gamma ray and cosmic rays. Most of the communication systems which we use in our daily day-to-day life are in VHF and UHF band. Some of the other devices which are used for communication, but we do not classify them as communication devices, are operating in infrared band like our remote controls for most of the electronic devices. Then another spectrum which is used sometimes for communication is visible spectrum, where laser communication is used at some point. You can see different applications which have been planned for different electromagnetic spectrum frequencies. For low frequencies, main applications are navigation and time standards. For medium frequency, it is marine or aircraft navigation, AM broadcast. High frequency, this is the band in which most of the amplitude modulation broadcasting or mobile radio is done. Very high frequency for line mobile, FM or TV broadcast. Ultra high frequencies for cellular phones, mobile radio, wireless LAN and personal area networks. Super high frequencies are used for satellite, radar, backhaul, TV, the direct to home connection which we use through dish antennas, wireless LAN and 5G cellular communication. Then extremely high frequencies are used for satellite, radar, backhaul, experimental and 5G cellular communication, and extremely high frequencies in the range of terahertz are used for mostly research and development purpose. Coming to the next block, which is receiver. Receiver receives signal from the channel which has been contaminated by different kind of impairments like noise, channel distortions and interference. Receiver's job is to recover the message signal from the received signal. Based on the kind of modulation which is used at the transmitter, the receiver may perform some kind of demodulation, which is if the message signal is transmitted by a carrier modulation, the receiver performs carrier demodulation to extract message from sinusoidal signal, or if the message which was communicated was digital in nature, then receiver will also perform signal detection so that you can identify the right message even in the presence of noise. Output of the receiver is fed to output transducer. It converts the electrical signal which has been received by the receiver and has been decoded into a signal which is useful for the receiver, like you can convert electrical signal to acoustic signal or images. Examples for this would be speaker which converts the electrical output signal into a voice signal, or display units which can be used for displaying images or video or any other kind of text information which has been received. This concludes our functional description of the electronic communication system. What we have realized is that the center part of designing any electronic communication system is the transmitter, and the most important job performed by transmitter is modulation. So, we will spend few more slides on explaining what is modulation and what is the role it plays in the design of a communication system. So, modulation as defined earlier is just a mapping of information signal onto a carrier signal. A carrier signal can be a sinusoid or a square wave or any other mathematically described function. Typically, the kind of carriers which are used in communications are sinusoidal signals. A sinusoidal signal can be completely described by its amplitude, frequency and phase. Now, for mapping the information signal onto carrier, we can vary one of these parameters, amplitude, frequency or phase, as per the information signal, and we will have a resulting modulated signal. Based on what parameter of carrier has been varied by information signal, we have three different kinds of modulation techniques. Amplitude modulation, where the amplitude of the carrier signal is varied with the information signal. Phase modulation, where phase of the carrier signal is varied with the information signal, and frequency modulation, where frequency of the carrier signal is varied with the information signal. In the next slide, you can see an example of these three modulation techniques, where the first figure is a carrier, sinusoidal carrier, the second waveform is information signal, and third waveform is the amplitude modulated carrier, where we can see that the amplitude of carrier signal is varying with the amplitude of information signal. In the fourth waveform, what we see is that the frequency output of the carrier signal is varying with the information signal, though it is a phase modulation, but the ultimate effect what we observe onto the carrier is the frequency variation. This will be explained later in the topic of phase modulation, that why when we vary phase of the carrier signal, still the observed frequency is also changing. And in the fifth waveform, what we see is that the amplitude stays constant, and as the information signal is varying, we have frequency of the carrier varying. These three variations can be decoded by the receiver to extract the information signal back. Now, we come to a point where we need to understand that why do we need to have modulation? What is the basic purpose of having modulation? So, modulation in any communication system leads to three kind of improvements which are fundamental to design of a communication system. First, it allows to reduce the hardware requirements. Second, to allow for signal multiplexing. Signal multiplexing means we can transmit multiple information signals onto the same channel. And third, to match the transmitted signal characteristics to the channel characteristics. These 3 points are described in the further slides. So, to reduce hardware requirement, we have to understand first what is the meaning of that. In order to design efficient wireless system, we need to have efficient radiation reception at the transmitter and receiver, which is achieved by antennas. So, antennas to have efficient radiation and reception, they need to have a height which is equal to the quarter of the wavelength. Now, if we look at the signals like voice signal, which has a spectrum around 3 kilohertz, quarter of the wavelength would mean antenna size of around 25 kilometers, which is very impractical. Whereas, if this information signal can be mapped onto a carrier which is of 3 megahertz, it will reduce the required antenna size to 25 meters, which is a very manageable height. So, what modulation does is that it allows the hardware to be manufactured in a very practical way. Signal multiplexing, it allows for the different information signals to be transmitted using non-overlapping frequency bands, thus allowing for efficient utilization of the channel spectrum. For example, if we look at transmission of voice signals received from various information sources, if we transmit them without modulation, then all these signals will overlap, but by selecting proper carrier frequencies and using modulation, we can transmit them so that the spectral occupancies of different information sources are non-overlapping without causing any degradation to each other. This is explained in the next slide, where we can see that there are two signals, signal 1 and signal 2, and if we look at the signal spectrum, signal 1 and 2 occupy almost the same spectrum. So, if we transmit them without modulation, they will interfere with each other, but if we select the carrier frequency suitably, then we can transmit them on the same channel without any overlapping or causing any interference to each other. So, this is another use of modulation which allows us to have very efficient utilization of channel, and we will see more about this in the topics of amplitude and phase modulation. The third and another important aspect of modulation is that it allows to match characteristics of the transmitted signal to the characteristics of the channel. Typically, if you look at any communication channel, most of the channels are having band pass characteristics, whereas most of the information sources have low pass characteristics. So, if we want to communicate information signals directly onto the channels, they will suffer huge amount of attenuation, and the amount of power required for transmission will be very high. But if we use modulation, modulation will allow to translate the frequency components of information signal from low pass to band pass range, and we can always match the spectrum of transmitted signal to the spectrum or the characteristics of the channel. So, with this, what we have learned is that use of modulation is essential to design of electronic communication system. To summarize, today we have learned about the basic building blocks of a communication system, like we have looked at what is information source, what is input transducer, what is the role of transmitter, what are different kind of medias which can be used for transfer of information over time or space, or then we looked at what are the different functionalities of receiver, output transducer, and the different kind of information sinks. After that, we have also looked at the electromagnetic spectrum, its designation, and various applications, how electromagnetic spectrum is utilized for different communication based applications. After that, we have also looked at what is modulation and what is the need of modulation in a communication system. To summarize, a modulation allows for reduction in the hardware requirement, it allows for the information characteristics to be matched with the channel characteristics, and also allows for the spatial multiplexing of the signal. Multiplexing is essential to design of an efficient communication system. By multiplexing, we can transmit multiple signals onto the same channel, whereby making it cost effective and something which can be made for masses. With this, we conclude today's lecture. Hope you have enjoyed this session.